And you will get a link by tomorrow morning telling you how to watch this.
Okay.
Okay. Now, I don't see the top of 1, although you can verbalize that. Do you want to begin at 1 or 2 or 3? Whatever.
We can just start with 3 because it's
okay. Let's start with 3. All of these problems on this page are factoring problems.
Yeah.
Basically, what you do is you start at the top left and work your way through both numerators and both denominators and see if you can factor them. Okay, so let's start with the top left.
We're doing number 3, correct?
Yeah, in fact, let me blow this up a little bit because it gives me a little more writing room, I believe. Oh, hold on a second, I gotta do it this way. Yeah, that way it gives me some room to write. And now I'll take a screenshot of that. Okay. So factor that.
Would you factor out an x and then?
Let's talk about factoring. The priorities that you do when you try to factor something. Okay, first thing you always look for is what? What's that called?
What's that?
Didn't catch what you said.
Greatest common factor.
Okay. And the second thing you look for right now. Are you hearing that feedback?
Yeah.
What that may require you to log off and log back on. Whenever that's happened, that usually is a pretty good. And let's have you do that. Because I can't. I feel like I'm talking over. So write down the mean. Let me give it to you again. You got a pencil?
Yeah.
892.
892.
554.
554.
Now it's gone. We don't need to do it.
Oh, okay.
The echo is gone. I was getting a serious echo for a while.
Yeah.
Okay. So let's get back to these problems. So we've got greatest common factor.
Okay, isn't there not a greatest common factor there other than...
There's not a greatest common factor, but what I want you to do is go through these 3 priorities in order of priority. Second,
yeah,
DOPS. Is this DOPS?
Yeah.
Okay, it's difference of perfect squares. So how does that factor?
Yeah.
So I'm going to write it over here.
Oh, x plus 4 times x minus 4.
Okay, good. And then the denominator.
Isn't that, can't you not factor that?
Leave it like that, but it actually makes more sense if I write it like this. That's what that means. X minus 4 quantity squared means x minus 4 times x minus 4. Okay? Now factor that. And that one falls under what I call quadratic factoring. In other words, when you have an x squared and an x and a number, you have to factor it like a quadratic.
Okay. I'm trying to...
The technique, I don't know if we've talked about this in our previous session or not. I don't know if we had time to get to this. But when you're factoring an elementary quadratic, which is pretty much everything up to question 8, all of a sudden in question 9, we see a quadratic that's got a 4 in front of the x squared, and another one that's got a 3 in front of the x squared. Those are beyond elementary. Those are harder to factor, but not impossible. It's just that the elementary ones are really easy to factor using my system. In my system, the first step is you split up the x's. What's the second step? Do you know?
Then you
determine
I think I wrote this
both
down.
signs, not just one sign, both signs. What do the signs have to be?
The signs both have to be negative.
No, I couldn't get a negative number if that were true. Because
one
L FOIL is those last two numbers are multiplied together. So if I'm looking at negative 18, remember what we're doing with this is factoring is the reverse of foiling. So when you see a negative 18, the only way that could happen is if the signs are opposite. So that's step 2. And then step 3 is factors of 18 that, here, let me point, factors of 18 that subtract because of that negative sign that I'm pointing at to the number 3. Well, what two factors of 18 subtract to 3?
3 and negative 6.
I prefer to think about it as 3 and 6. Those two factors subtract to 3. Forget the sign for a moment.
Okay.
Okay? In other words, we look at the negative sign in front of the 18, but only because that tells us that we want factors of 18 that subtract to the number 3. Well, we found it. And now the fourth step is you put the larger of the factor, whatever it is, the larger one, with the sign of the middle term. That's a negative also. So the 6 goes with the negative. The 3 goes with the other one, and that's how you do elementary factoring, and it's never any tougher than that.
Yeah.
Okay? So I don't know if you learned the diamond method or the California method or whatever they're teaching these days. I don't like either one of them, to be honest with you. And there's no need to make it that complicated. Not with these elementary problems, or these, I should say, elementary quadratics. So let's do the same thing here. First step. This is for the bottom right. That's for this one here.
Yeah, so then it's a plus and a minus.
Okay, so it's x and x, step 1, and then it's a plus and a minus. And notice I could do minus and minus, or minus and plus. That's the same thing. There's no difference in this case between plus minus and minus plus. When you get some of these harder ones, there is a difference. But on these elementary ones, there's not. Plus minus is the same as minus plus. So what's the third step?
Then you find two factors of 24 that subtract to 2.
Perfect.
Or negative 2.
Nope, just 2.
Oh yeah, just 2.
Don't worry about the signs at the moment. Just find two factors of 24, not negative 24, because when you deal with those signs, it makes it harder to come up with these real simple answers. Whereas if we just look for factors of 24 that subtract to the number 2, everybody can come up with that. That's 6 and 4.
Yeah.
And now there's a fourth step. You have to figure out which number goes with which sign. Where's the 6?
So then the 6 goes on the negative term.
Correct. The sign of that middle term right there.
Yeah.
4 goes there. That's the first step of these problems. And then the rest of it is just canceling. So tell me what I can cancel.
So then you can cancel the x minus 4s in the first part of the equation.
I can, well, let's start from the top left. I can cancel that with that. Now I can cancel that with one of these only.
Mm-hmm.
And then I cannot cancel the x plus 3 with anything, but I can cancel the x minus 6 with the x minus 6, and that leaves me with x plus 3 over x minus 4.
Yeah.
My answer. And that's how every single one of these is going to play out. What this really is an exercise in factoring, which is good because you never can get too much practice. And you need to be good at it. Factoring is a crucial skill in math. So practicing it is great. And they throw you these kind of problems because it gives you practice with all three methods of factoring. In other words, you don't get a whole lot of greatest common factor in these kind of problems, but you definitely get some dopes and you get some quads. So let's have you do 4.
Okay.
Now, is it confusing to you when I'm writing over top of letters? Because I can do this a different way. I can bring up my other sheet and write on it, but then I would have to I'd have to copy the problem over. So if you're okay with this, I'd like to stick with doing it. It's quicker.
Yeah, I'm okay with it.
Okay, so start with the upper left numerator.
Okay. So then you have to find 2 factors of 6 that go to 1.
You got to be more specific. Start with what signs are. In other words, don't ignore the first 2 steps.
Yeah, so it's x and x, and then it's plus and minus.
Okay, now we're ready for the 3rd step. Factors of 6 that go to 1, what does that mean? Factors of 6 that do what?
That subtract to 1.
Okay, perfect. What factors of 6 subtract to 1?
2 and 3, or 3 and 2.
Okay. Which one goes with which sign?
So then the 3 goes with the negative, because it's the bigger one, and that's the middle term.
Perfect.
And plus
Perfect.
2.
Elementary quadratics do not get harder than that.
Yeah.
Other than having bigger numbers that are maybe a little harder to factor. But that required all 4 steps. Some of them don't even require 4 steps. This one right here is only going to require 3 steps because our signs are going to be both plus and there won't be any decision as to where to put the 2 numbers. So that's why I say this is the hardest you're going to see. Okay, factor the lower left denominator.
Okay, so then it's going to be plus and minus again. Or x and then plus and minus.
Okay.
And then factors of 10 that subtract to 3 are what?
Which are?
Oh, 5 and 2.
Okay. Which one goes where?
5 goes with the plus, and then 2 goes with the minus.
Perfect. You are an expert factor. I can tell right now. It's simple if you keep it simple. Now, when you get into these harder ones, it's more of a trial and error process. And we'll go through some of those. But let's make sure you can do all of these. And as soon as we get enough of these done, then we'll jump to this harder one here before our session's over. So we're factoring the upper right numerator.
Okay. It's going to be x and x again. And then it's going to be plus and minus again. And then factors of 15 that go or subtract to 2. 5 and 3.
Okay.
So then 5 goes with the plus, and then 2 goes with the negative.
The 3 goes with the negative, yep.
Or the 3, yeah.
Okay. Let's just, okay, go ahead and then do the bottom, right?
Okay. And then x and x again. And then
The signs have to be what?
the signs have to be positive.
No, they have to be the same.
Or yeah, they have to be the
Which
same.
means either negative, negative, or positive, positive. And you can tell
Yeah.
which by looking at that right there.
So it's going to be negative, negative.
Negative, negative. Always.
Okay.
And the sign on the middle term tells you. When you know the signs have to be the same, that's why it's crucial to do that as a second step all on its own. Because sometimes it's negative, negative, or positive, positive. Sometimes it's positive, negative. So the third step here.
And factors of 9 that add to 6.
Okay. What are those?
So then 3 and 3.
And there's no decision to be made. In other words, this is only 3 steps, not 4, because it's an easy thing to do. Okay. Tell me what I can cancel.
Starting with the top left, you can't cancel the x plus 2. The x minus 3 and one of the ones on the bottom right.
Uh-huh.
And then the x plus 5s. And then the other x minus 3s. So then it's just x plus 2 over x minus 2.
Uh-huh. That's exactly right. So, I feel confident you know how to do those. However, before we jump, let's just talk about finding factors of numbers. If I want to find the factors of 64, I start there. And then if I can, I cut that in half.
So 2 and 32.
Right? In other words, by cutting that in half, I have to double this one. If I can again, I cut it in half. I got to double that one. If I can again, I cut it in half, double that one. Now if I cut it in half, I get the same 2, so I don't bother to do that. Okay?
Yeah.
So that's all my factors. Now let's take a number like 27. I'm looking for factors of 27. I cannot cut that in half, but I can cut it in thirds. So 9, and I'd have to multiply that by 3. I could cut it in thirds again only, but it doesn't produce a different set of factors. So those are my only set of factors. Now let's take a number like 50, factors of 50. Well, my first step, cut it in half, double. Now, I cannot cut that in half. I cannot cut it in thirds. If I can't cut it in half, I certainly can't cut it in fourths. I can cut it in fifths. So that becomes 5, and I have to multiply that by 5. That's how you factor a number.
Okay.
Okay, and sometimes you won't be able to do sixths, but you might be able to do sevenths. In other words, if I'm factoring 49 and 1, I can't cut it in half, thirds, fifths, or sixths, but I can cut it in sevenths. So you just go up the line. Unless you have a prime number, and then you're not going to be able to cut it in anything but the original 2. Okay, so let's skip some of these. And if we have time, we can come back and pick them up. Some of these, let's do. They're different. Everything up to 6 is the same. 7 is slightly different.
Yeah.
Factor 7. Numerator.
Okay. So the first one, 5x minus 50, is it? Can you just...
What's the first thing you look for?
Greatest common factor, so 5.
Okay. What's left?
So
what goes in the parentheses?
Then x minus 3, or 3 minus x.
Yeah, here's how you figure it out. You take the factor you came up with, 5, and you divide each term by it. And that's what goes in the parentheses. 15 divided by 5 is 3. 5x divided by 5 is x. And then you check to make sure that you got the same thing. Is this the same as 15 minus 5x? Yes. Okay, now do the lower left denominator.
So then it's x and x. And then
signs.
Minus and minus. Or no, plus and minus, because the second one's negative.
Anytime you see a negative in that, in front of that constant, they're opposite signs.
Yeah.
The only way you can get a negative. And what are the numbers?
And then, so factors of 6 that go to 1 is just, 2 and 3. That was
that's okay. Right. Okay. Yeah. The 3 goes where?
The 3 goes next to the negative sign, and the 2 goes next to the plus sign.
Okay. This problem is going to illustrate something quite useful that we haven't seen yet. Okay. Now, what do we do with that division sign right there?
You flip the terms and then make it a multiplication.
Yeah. So this is really a multiplication problem. It's not a division problem. Yeah. All division problems are basically multiplication problems, just like all subtraction problems can be turned into addition problems. So what goes on top, I'm factoring this bottom right.
So then it's x and x. X, and then...
Don't try to figure out the numbers in advance of the signs. Figure out the signs next.
So then it has to be positive, or both are positive?
Correct. Now get to the step 3.
So then factors of 8 that add to 6 is 2 and 4.
Okay.
And then 4...
That's it. There's no deciding. In other words, since they're both positive, I could put the 4 on the left and the 2 on the right, and I got the same thing. Okay. Now, the bottom, we've got a 5x. That's fully factored already. So that's our problem. So I can cross the x plus 2 with that x plus 2.
Yeah.
I can cross out that 5 with that 5. So what I would appear to have is 3 minus x times x plus 4 all over x minus 3 times x. But this is the first time we've seen that. This 3 minus x over x minus 3 is negative 1. No matter what the numbers are. 7 minus x over x minus 7 is negative 1.
Yeah.
So I actually can do something with this 3 minus x over x minus 3. I can cancel them, but I have to leave behind a negative sign.
So then it's x plus 4 over negative x.
Well, I've got 2 x's. I got this x over here, and I got this x over here. So it's x plus 4 over negative x squared, the negative not being squared. So unless I missed one, I think that's what I have. Did I miss one? I might have missed one. Yeah, I did. I don't have an x squared there. And the negative sign can go with the x, it can go with the numerator, or it can go out front. I actually prefer to put it out front like that. Okay. Did I do this right? My scribbling is such that I can't follow my own scribbling. Yeah, I went to explain this and I lost track of what I had done down there. Yeah, I only have that x left. I don't have two of them. In other words, I'm not looking at that anymore. Or am I? No, I'm not. Okay. So, like I said, this negative sign can go in the numerator, the denominator, or out front. Where it cannot go is in front of the numerator's x. Let's talk about that just briefly. That is not equal to minus x plus 4 over x. I have to put parentheses around that, and when I do distribute that negative sign to the numerator, it becomes negative x negative 4. So that would be the same as that. So that's one of the reasons I prefer to put the negative sign out in front of the fraction and not with either the numerator or the denominator. Unless I have subtraction going on in the numerator, and then I don't mind putting it. In other words, if that was x minus 4, well, now I would put it with the numerator because I could replace that with 4 minus x. And now I have no negative signs. I got 4 minus x over x, which is the best answer. But I can't do that. In other words, I cannot, if I distribute this negative sign to this numerator, x plus 4, it becomes minus x minus 4. All right, here, let me, excuse me, I had to get up and shut my door. All right, so that was different in two ways. We got to cross out, the basic thing is a minus b divided by b minus a. Regardless of what a or b are, it's always minus 1. Okay?
Yeah.
That's the new thing we learned with that problem for the first time, is we could do that little technique. That's the one most people miss. Now, without knowing whether 17 is a factor of 119, I would bet dollars to donuts that it is.
Yeah.
You have your calculator?
Yeah.
Got to go in there 7 times.
7 times 17.
So you would factor out 17 and be left with x plus 7.
Yeah.
And everything else would be the same. You're going to still flip. Don't forget to flip because of that division. And that doesn't factor. I can't pull a greatest common factor out. I can't find difference of perfect squares. I can't, it's not a quadratic, so I can't quadratic factor it.
Yeah.
Okay. Let's go on. Let's see if we can find something harder here. Or not harder as much as different. Let's do 9. Start.
Okay.
And let me start my writing a little higher so it doesn't get confused with the problem. I still didn't write it high enough. It's okay. You get the idea. So do that numerator. Now we're dealing with second degree factoring. And this involves a lot more trial and error. In fact, let's just factor this expression so we can go over factoring these harder ones. When I have 2x squared minus 5x minus 3. First step and second step are the same as with the easier ones. First step, you got to split up the x's. How do I split it up?
Is it still just x and x, but then...
No, that wouldn't multiply to 2x squared. Whatever I write has to multiply to 2x squared. Remember the first step of FOIL. is to multiply those first two terms together. That's how you get this term.
Okay, so it's 2x and x.
There you go. What are the signs?
Then they're both negative, or the one's positive, one's negative.
Okay, now, yes, in this case, positive and negative is not the same as negative and positive. So I have to write both of them. In other words, I have to allow for all four situations. And they're not the same because this number over here is going to multiply 2x, whereas the number in the middle is only going to multiply x. So that's why there's a difference between plus minus and minus plus. Now, if there was a 2 in front of this x on the right, then plus minus would be the same as minus plus. They don't have to both be 1. They just have to both be the same for it to not make a difference. Okay?
Okay.
Now, give me factors of 3.
3 and 1. 1 and 3.
That's it. So, I've got 4 possibilities here. And when I say trial and error, I'm going to use trial and error, but the first trial will eliminate another wrong answer if I've got it wrong. And I don't even know how I'm going to do this. I'm just going to start doing it this way. 3 and 1. Okay, that's one possibility. Now, the way I determine whether that's correct or not is by doing the inside of FOIL and the outside, adding them together. And if that's my middle term, then that's the correct way to factor it. Well, what's the inside?
So then that's 3x.
What's the outside?
And negative 3.
Negative 2x. The outside is you're multiplying 2x by minus 1.
Oh, yeah.
Okay?
I was multiplying.
Add those together, you get x. That's not our middle term. Not only is it not our middle term, but it doesn't have the right number in front of it. Which means I can eliminate trying the 3 with the negative sign and the 1 with the positive sign. The fact that I do not have a 5. Let's say that that came out to be plus 5x. Well, that's the right number, wrong sign. Then I know the right answer is just to move the 3 down to the negative and the 1 down to the positive. But when I don't come out with even the right number, then the 3 doesn't go on the left and the 1 doesn't go on the right. So let's switch them. Let's put the 3 on the right and the 1 on the left, like that. And now let's do our inside-outside test again.
So then x plus or minus.
Always put the plus sign in there too.
Oh, so then that's 6.
Minus,
so then
that's minus 6x. Add them together.
Yeah. That's negative 5x.
That's our answer. We got our answer. Now, had that been plus 5x instead, then I know my answer is just to move the 1 down to the negative sign and the 3 down to the positive sign.
Yeah.
So these second level quadratics, you can't use the same rules. You got those rules where I said factors of 3 that add or subtract to the number 5, those go out the window. Once you're to second level, those only work if it's x and x. The moment you get anything other than x and x, forget steps 3 and 4. They're not the same. Steps 3 and 4 become trial and error. Okay, if you're lucky, they will give you simple problems like this, where there were only 2 factors for the number 2, and there were only 2 factors for the number 3. But notice that still gave us 4 possible combinations. Imagine if they made that 12, and that 30. Now, do you know how many combinations there are and how hard that would be to factor?
Yeah.
Because I wouldn't know whether it was 4x times 3x, or it might be 6x times 2x. It could even be 12x times x. And then 30 has gobs of factors. So I'd still be working on that problem. And you have to check every single trial to see if you can produce that middle term of 5x. So the more factors that these numbers have, the harder the problem becomes. And they're probably not going to give you a lot of problems that have complicated factors. None of the ones I see in this problem are complicated. So let's see. What did we end up with? We ended up with 2x plus
1 times
x minus 3.
Yeah.
So that takes care of that. Now do the bottom left.
Okay. That's
Let's do it step by step. Again, there's only one set of factors for the number 3, so there's not going to be that many possibilities.
yeah. So then it's 3x and x.
In fact, it's going to be even easier because both signs are going to be what?
Or the same. The negative.
Both negative.
Yeah.
Now we only have 3 factors for the number 3. That's 3 and 1. And I got to get up to 10. Which side do you suppose the 3 has to be on?
On the right side.
Yeah, because that's the number that's got to multiply that 3x to get to 9. And then the 1 goes there, which gives you another x. That produces 10x.
All right. That was not so tough.
No, that one there was pretty easy. But that's because they didn't give you very many factors. They're not that hard if you don't have that many factors. Okay, now 9x squared minus 1. How does that factor?
Grace, difference of okay.
Yes, it is difference of perfect squares. Most people don't necessarily recognize it as perfect squares. They see that that is a perfect square number, but they don't realize that 1 is a perfect square number, but it is. So,
So then,
what is it?
Wait, so do you factor out the...
Take the square root of each side. Take the square root of 9x squared. That's your first term.
3x. Oh, okay, so 3x.
And these you can do one at a time. When you're doing difference of perfect squares, figure out the first one and then just make the second one the conjugate. I don't have to do any thinking at all. It's automatically 3x minus 1.
Yeah.
Okay? So all you really have to do is take the square root of that number, take the square root of that number, and make that your first term.
Yep.
And you can make it minus, and just so long as the second is plus, or the opposite. Now, how about this bottom here? There's a second degree. And it's a little tougher because there's more than one set of factors for 4. So this is definitely going to be tougher than that one. There's going to be more possibilities.
Yeah.
What did we start with? 2 and 2 or 4 and 1?
2 and 2.
Always start with the 2 closest factors when you're doing trial and error. Only because the state of Colorado, I've been tutoring for 8 years, and 90% of the time on these tougher quadratics, the factors are the 2 factors that are closest together, believe it or not. They want to make it easy, so they want to give you a place to start. What are my signs?
Then they're both plus.
Well, that doesn't leave much options. It's either 1 and 1 or it doesn't factor, and that does. That works. What happens if it doesn't work?
Then
Go back and try 4x and x.
Yeah.
You still have to use 1 and 1 and plus, but you do have one other choice, which is to use 4x and x, which does not produce a middle term of 4x. So that's not the correct answer. This is. But that would be your second step. And what if that didn't work? What do you have to do?
And you.
Greatest common factor is first. Dopes is second in terms of what you're looking for. Quadratic is third, but what if quadratic doesn't work? Then you got the quad formula.
Oh, yeah, quadratic formula.
That's the last resort. If nothing works, you have to use the quadratic formula. And the quadratic formula won't produce nice looking answers like this. It'll produce square roots, irrational numbers, irrational factors. It's only if it factors nicely that you get nice looking factors like this. And so if it doesn't factor, you're going to get weird looking factors. They're still factors, but they're irrational factors. Quadratic factoring always produces irrational factors, like square root of 17, things like that. Okay, now let's see. Can we cancel? Yeah, I'll do the obvious cancels. I know you got this down at this point. This 3x minus 1 can only cancel with this 3x minus 1, not the 3x plus 1.
Yeah.
So what's my final answer?
3x plus 1 over 2x plus 1.
Uh-huh. And that cannot be simplified. Okay. Let's have a look at some others here. Let's see if 10 is... 10's got something different to it. Do top left.
Is that just... Isn't that difference of perfect squares 2, but they're both 1?
You tell me. Don't ask me.
So it's x plus 1 times x minus 1?
Uh-huh. There's a reason I say that. I get a lot of students that they're not quite sure of themselves. And so they tend to give me answers by saying, isn't that so-and-so? And I always encourage everybody to have confidence in your answer. You know this. I know you know it. So you tell me the answer with confidence. If you're wrong, the worst thing that can happen is I'll tell you, no, it's this way. But I'd really like to see you take that level of confidence that you know what this is.
Mm-hmm.
Because I know you do. You're doing all of these correct. So do that lower left denominator.
So then it's x and x. And then the signs are plus and minus. And then factors of 7 that subtract to 6 is 7 and 1, and the 7 goes with the negative term. And then that's factored.
Okay. Now the right, this is division, so make sure you flip before we multiply.
And then x plus 7 you can't factor, or x minus 7, I mean, you can't factor.
That's already fully factored. So how do I factor this?
Then if it's cubed, then it's x squared and x.
No. Go through your priority.
Oh, yeah.
That's the first thing you always look for.
Greatest common factor is
X.
Oh, yeah, it is x.
I can pull an X out of that. What's that leave behind?
So then x times x squared plus x minus 2.
That factors again. So factor that.
So then that's x times x. And then it's plus and minus. And then factors of 2 that subtract to 1 are 2 and 1. And then 2, or wait.
Yep, you're right on.
2 and 1. So then 2 goes with the plus, 1 goes with the negative.
Very good. You got this down. So that replaces that denominator. So other than being difficult to read now, let's see what we can cancel. There's an x plus 1, there's an x plus 1. There's an x minus 7, there's an x minus 7. There's an x minus 1, there's an x minus 1. What are we left with?
Just x times x plus 2.
Goes in the numerator.
Oh, just 1 over x plus
Right.
2? Or
When I cross these things off, that's a little bit misrepresentative. What I'm really doing is dividing top and bottom by x plus 1, and I'm leaving a 1 behind. So
it's 1
one's behind.
x
Every time I cross something out. So yeah, the answer is 1 over what?
X times x plus 2.
Yeah, and don't multiply that out. This is actually a preferable answer. You could, in other words, it'd be the same if you said 1 over x squared plus 2x. But the reason a factored answer is a better answer because I don't know what I got to do with this answer. Maybe I got to take that answer and multiply it by x plus 2. In which case, I wish it was in factored form. I'd be able to do it easier. So that's why factored answers are better. Unless your teacher has specifically said, multiply everything out for your final answer. But I can't imagine a teacher that would say that because factored are definitely better than non-factored. Notice that if all these problems were given already factored, how much easier they'd be. It's only the fact that they've multiplied everything together to produce these quadratics that makes it tough because then we have to factor. Okay, let's see if I can find something different still. Well, we only got 2 minutes. Let's see what else we're looking at here. Let's look at 12 in our last 2 minutes. Factor the top left.
Then it's just x plus y times x minus y.
Good.
Over then just x plus y.
So that cancels with that. Now I meant to write a y. That cancels with that. What's my answer?
It's just 1.
Good. Blake, I'm going to let you go.
Thank you.
Before I let you go, actually, can I get a couple of things from you? I need your email address so I can send you a link to this recording. And I need your mom or dad's email address so that I can send the envoys to them.
Okay. Which are you? Do you have like a pen?
I do.
Or I'll just email it to you.
Okay. Yeah, you emailed me this, so you have my email. So I have yours already, right?
Yeah.
Yeah. Yeah, I'm sure that I do, but let me just, bmanfowler@gmail. So the only one I need is who I should send the envoys to.
Okay, I'll email you my stepdad's email.
Okay. Sounds good.
All right.
And
Thank you.
I won't send an envoice after every session, but after a couple sessions, I'll probably send an envoice if they
Okay.
and they can wait for an envoice if they like. Some people pay it in advance, but it doesn't matter to me. Okay, so I will send you a link tomorrow morning to see this session if you feel like reviewing it. But I feel good about it. I feel like you really learned this, don't you?
Mm-hmm.
Yeah. Okay. Well, Blake, have a good rest of your day, and I'll talk to you next time.
All right, you too, and thank you.
Yeah, and you close out of this GoToMeeting by just hitting the X in the upper right-hand corner.
Okay.
All right. Good night.
Good night.